Today we're going to look at function transformations. Function transformations uses those basic shapes that we talked about in the last video. So you should be very familiar, and in fact I would encourage you to memorize those 5 basic shapes that we talked about in the last video. In this section we're going to use those 5 basic shapes and we're going to move them around. So this is called translations of functions. So that means to shift a graph vertically or horizontally. So what happens when we get a vertical shift? So to get a vertical shift for a graph, we have to add or subtract a constant to the outside of the primary function. Okay, so if I come down here, I have g of x equals absolute value of x plus 2. Here we are adding a 2 on the outside. So it's outside of those absolute value bars. So that's what we would call adding a constant to the outside of the primary function. Here in function h, we have h of x equals absolute value of x minus 1. Here we are subtracting to the outside or from the outside of the primary function, meaning we're subtracting outside of those absolute value bars. What we are interested in this section is what happens to those graphs when we make changes to the function. So in this case, if I'm adding or subtracting on the outside of the function, what changes will result to the graph? So we're talking here specifically about vertical shifts, and vertical shifts are only going to arise when you are adding or subtracting a constant on the outside of that primary function. So what I would like to do is to pull up Desmos, and we're going to look at some of the effects these changes have on those basic shape graphs. Okay, so here I have absolute value. So here's our absolute value function. It's that V-shaped graph with that origin point 0, 0 at the very bottom of that V-shaped graph. So what happens if I take the absolute value function and I add a 2 on the outside of those absolute value bars? So what we're going to see is that's going to shift our graph up 2 units. So here's 1 and here's 2. So it shifts our graph up 2 units. Notice everything else looks like it's exactly the same shape. It has not changed shape, it's just shifted the entire graph up 2 units. So every single point on this graph, so the point 0, 0, is shifted up to the point 0, 2. So we're shifting up, which means basically our y value is going to change. And if I move up 2 units, my y value increases by 2. Now this happens not just for that special origin point, but for every single point on this graph. So here I have the point 2, 2, and if I shift that point up 1, 2 units, now that point becomes 2, 4. There we go. So the x value itself stays the same, but the y value increases by 2 when we shift that graph up. Okay, so it happens here as well. Take the point -2, -2. If I shift that up 1, 2 units, that means that I get to -2, 4. So the y value increases by 2. Okay, what happens if we subtract a number on the outside of that absolute value function? So we notice that the graph is now going to shift down 1 unit. So the original graph is there in red. So my original point there was 0, 0, and now that point becomes 0, -1. So all of the y values now are decreasing by 1. Okay, so the point, let's say here, on the original graph, -1, -1, if I can find it, there you go. If I shift that point down, that point, the y value will change, it will decrease by 1. So 1 minus 1 gives me 0. So this point then shifts down to become -1, 1. So that happens for every single point on this graph. It shifts down by 1 unit. Okay. So what happens if I were to add a 5? Right? So instead of adding a 2, what happens if I add a 5? Well, the entire graph shifts from its original point, 0, 0. We shift up 5 units, and that point at the very bottom of that V-shaped graph, what I would call the shifted origin point, shifts up 1, 2, 3, 4, 5 units and becomes 0, 5. And the rest of the graph comes along for the ride. And we notice that the shape of the graph is still that V-shaped graph, recognizable as that absolute value function, but it just has been shifted up 5 units. Okay, what happens if I subtract a 3? Instead of a 1, I subtract a 3. Well, the entire original graph then shifts down 3 units. What I'm going to ask you to keep track of is what happens to that 0, 0 point. What does it become with these shifts? And in this case, if I shift down 3 units, that 0, 0 point becomes 0, -3 on my graph. Okay, so basically anything I add or subtract on the outside of the function is going to shift the graph vertically, up or down, according to the sign and according to the number. Okay, so the shape itself, you'll see here, does not change. It's just moving up or moving down according to the number that's being added or subtracted on the outside of that primary function. So this happens not just for absolute value, but it happens for all of our basic shapes. So here's our square function. If we add a 4 on the outside of x squared, so on the outside of the squaring, I come and I add a 4. Can you guess what's going to happen? Okay, and let's look at what that picture would look like. Okay, it's that square function shifted up 4 units. So instead of starting at that origin point 0, 0 at the bottom of that U-shaped graph, now the bottom of that U-shaped graph starts at 0, 4. So all the y values have now increased by 4. Okay, what happens if we do x squared? And on the outside of that primary function, we subtract 3. Okay, so the graph is actually going to shift down 3 units. So instead of starting again at 0, 0, where that original basic shape starts, it shifts down here to 0, -3. So all the y values are going to decrease by 3, and the graph shifts down 3 units. So this would happen for any of the numbers I would add or subtract on the outside of the function. Okay, notice that the shape itself is not changing. It's just where that graph starts. So where has it been shifted to, either up or down? We're going to keep track of that origin point. Where does that origin point shift? Okay, it works for square root as well. Here's our square root function. If I add a 3, the graph shifts up. It starts at 0, 3, curves up and to the right. If I subtract a 4, now the graph starts down here at 0, -4 and curves up and to the right. So the shape itself, again, is staying the same. The graph is just shifting up or down according to the number we're either adding or subtracting on the outside of that square root function. Okay, it works for cube. Here's our cube function. Here's our original basic shape and the origin point there, right there at 0, 0 in the middle. If I add 2, the graph shifts up 2 units. Same exact shape, the origin point has just moved up 2 places. If we subtract a 3, same basic shape, but that origin point has shifted down 1, 2, 3 units, and now is at 0, -3. Again, the same basic shape, the shape itself is not changing, it's just shifting up or down according to what we've added or subtracted on the outside of that cube function. Okay, it works for cube root. Here's our cube root basic function. Okay, if I add a 3 on the outside, let's go with Bender. If I add a 3 on the outside, my original point, 0, 0, that origin point at the very center of that cube root function, is now starting at 0, 3. Okay, so the shape has not changed. We've just shifted that origin point up 3 units, and the basic shape comes along for the ride. If I subtract 2, okay, now that origin point, instead of being at 0, 0, is shifted down 1, 2 units, and then the shape is drawn from that new location, from that newly shifted origin point. So the shape itself is not changing. Again, it's just shifting up or down according to the number we've added or subtracted on the outside of that cube function. So what I'm going to ask you to do in your notes and on exams and homework is I'm going to ask you to keep track of what that shape looks like and what that newly shifted origin point will be. So let's look at these functions here. So g of x equals absolute value of x plus 2. Since we've added a 2 to the outside of that function, what is the graph of that going to look like? So the first thing that we're going to do for each one of these is we're going to identify what is the basic shape. So when you look at that equation, what name did you say? You said absolute value. So that's where that name comes in. When you know the name of the function, then you should be able to think about what's the shape for that name. That's that V-shaped graph with the origin point at 0, 0. Okay, so that's the first thing that should pop into your head when you read that function absolute value. You should think of that shape and that origin point. Okay, well, what are we doing? We're starting at 0, 0, but we're shifting that graph up 2 units because we are adding a 2 on the outside of those absolute values. So because of that absolute value of x plus 2, the plus 2 on the outside is going to shift that graph up. Okay. And what you want to be able to do then is to label what that point now would be. So the x value is still 0, the y value has moved up from 0 to 1 to 2, so 0, 2. Plot that origin point, shift that newly shifted origin point, and then draw the basic shape from there. Okay, so something else that we'll practice doing here as well, and I could ask you on a test, is now that you've shifted it, do you know what the domain and range of that graph would be? Okay, we'll give our domain and range of that graph in interval notation. So the domain from left to right would be all real numbers, because we have an arrow pointing left and an arrow pointing right. So negative infinity to positive infinity for that domain. The range, what's the very bottom y value of the graph? Well, that starts at 2, including 2. And then when I go to the very top of the graph, I see arrows, so that's positive infinity. Okay. Okay, if you had this on a test, what would I be expecting? Okay, h of x equals absolute value minus 1. Okay, so we'll graph that absolute value function. So I notice that I am subtracting a 1 on the outside of that basic shape. So that's going to tell me that I'm going to shift the graph down. Okay, so I'm going to go to my graph. I'm always going to start at the origin point. So I'm going to start at 0, 0, and then I'm going to shift 1 unit down. And I'm going to stop there, and I want to label that point. So I'm going to plot it and label it. So plot that point, label it. That would be an x value of 0, and now going down would be a y value of negative 1. Draw the basic shape after you shift that origin point. So there's my absolute value graph shifted down 1 unit. Can you tell me the domain and range of that newly graphed picture? Okay, the domain from left to right, looks like we have arrows on either end, so that's negative infinity to positive infinity. Okay, the range, we start at the very bottom of the graph and record the y value there. That's negative 1. And we always assume included, unless we see an open circle. So I'm going to use my closed brackets there. Then I go all the way up to the top, I see arrows, so that's a y value of positive infinity. Okay, so you should be able to know the basic shape, the original basic shape, know how to shift it, how to label that newly shifted origin point, and then draw the graph from there. And then after you've drawn your graph should be good enough to where you can look at that picture and tell what is the domain and range of that newly shifted graph. Now, if the graph can move up and down vertically, we think about it could also move left and right horizontally. So we're going to look at something called horizontal shifts. So if I wanted to make one of my basic shape equations or those graphs move to the left or to the right, what would I have to do? So in order to move horizontally, you have to add or subtract a constant on the inside of the primary function. Okay, so when I look at these two functions, g of x equals the absolute value of x plus 2, you see that the plus 2 is being added to the inside of the absolute value bars. Okay, so that's what we would call an inside change, and we are adding a 2 on the inside. Okay. Over here we have h of x equals x, absolute value of x minus 1. So the minus 1 is happening inside of the absolute value bars. So again, inside is important. Okay, so now we're subtracting a 1 on the inside. So let's see what effects these have on our graph by looking to Desmos. Okay, so here I'm in Desmos, and I have my absolute value function, that original basic shape, that V-shaped graph with the 0, 0 point at the very bottom of that V-shaped point. So there's our origin point. Okay, so what happens when I take a 2 and I add it to the inside of those absolute value bars? So what happens to our graph? It shifts horizontally. It looks like it moved to the left 2 units. So it shifted horizontally. Was that the direction that you thought it might shift? You might have thought it would have shifted 2 units to the right because it's a positive 2. When we add or subtract a number on the inside of the basic shape functions, it shifts left and right, but it shifts in the opposite direction that we would associate with the sign. So instead of shifting to the right 2, if I see a plus 2 on the inside, the graph will shift to the left 2 units. So that puts us at negative 2, 0. And of course, the V-shaped graph goes from there. So what happens when I do x minus 1 on the inside of those absolute value bars? I might think it shifts to the left, but in fact it shifts to the right because we're going to go opposite of the direction of the sign we see. So here we see that V-shaped graph shifted 1 unit to the right, and so that origin point now would be x value of 1, y value of 0, and then the V-shaped graph goes from there. So the graph will shift in the opposite direction that we associate with the sign if we add or subtract some number on the inside. So adding or subtracting a number on the inside will shift our graph left or right, that number of units, but in the opposite direction that we associate with the sign. Alright, so let's look at the effect that it has on some of our other basic shape functions. So when we're working with the square function, if I want to make an inside change, I have to include parentheses. So you'll see that I have parentheses around the x minus 3. That's how you know that you're on the inside of the square function. If you're making a change on the inside, you're making a change inside of the parentheses, and the squaring happens on the outside to the upper right of those parentheses. So here we have subtracted a 3 on the inside of our square function. This is our original square function. Okay, so can you tell me what would happen to this shape? Is it going to shift left, right, up, or down? Well, if I'm making an inside change, it's going to shift left or right. Okay, and since I'm subtracting, I'm guessing it's going to shift to the right 3 units. Okay, so there we go. So the graph shifted to the right 3 units, and our new origin point would be 3, 0. So an x value of 3, y value of 0. Okay, and then they'll draw that square function shape from there. Okay, what if I do x plus 2 inside of the parentheses being squared, where I've added a 2 on the inside of that square function? Okay, what's that going to do? Okay, so hopefully you thought it's going to shift to the left 2 units, and there it is. So there's that new origin point. Instead of 0, 0, it has shifted 2 units to the left at negative 2 for x and a y value of 0, and then the graph opens in that U-shaped graph up from there for that square function. Okay, so again, the shape itself is not changing as I shift this graph. Okay, so the shape itself is not changing as I shift this graph. We're just moving or shifting horizontally according to the number and the sign that's being added or subtracted on the inside of that square function. Okay, this also works for square root. Now for square root, if I want to make an inside change, I have to do so underneath that radical symbol. So the +1 has to be underneath that bar. Okay, so that bar is over the +1, that's an inside change. So when I look at my original square root function, how is the adding of the +1 on the inside going to affect it? So what is that going to do to that shape? So if I add a 1 on the inside, that should shift the graph to the left 1 unit. So my graph should start right here. So let's see what happens. And there we go. Okay, so now instead of starting at 0, 0, if I move to the left 1 unit, that puts me at an x value of -1, but a y value of 0. So now we have that newly shifted origin point, -1, 0, and then the square root function opens to the right from there. Okay, what if I subtract a 2 underneath that square root symbol? So the bar goes over that -2. What happens if I subtract a 2 on the inside? So we're going to say that if we subtract a 2 on the inside, that the graph then should move to the right 2 units, and the graph should start here at 2, 0, and then open to the right. So let's see if we're right. Yep. And so the point is 2, 0, and the graph opens to the right from there. So that origin point shifts to the right 2, and then the graph follows along. Okay, so the shape again not changing. It's just shifting to the left or to the right based upon the number and the sign that I have underneath. Okay, let's look at the next one. Let's look at the cube. In order to add or subtract something on the inside to make that inside change for the cube function, just like with the square function, we have to include parentheses. So everything inside of the parentheses represents that inside change. So it's parentheses and then that cube is on the outside of the parentheses. So in order to signify a inside change, we have to have the parentheses. So the -2 is inside of the parentheses. That means it's going to shift the graph to the right 2 units. There we go. And then that cube function opens up and to the right from that origin point and then down and to the left. Okay. What about x plus 4 inside of the parentheses and then cubed? So can you guess where that shifted origin point is going to be? Okay, so it starts here at 0, 0. We moved the graph to the left 1, 2, 3, 4 units. So we're going to plot that point there. This should be -4, 0. And there we go. Okay, and then once we plot that newly shifted origin point, then the shape stays the same. So we open up and to the right and then down and to the left. Okay, so the shape itself again is not changing, but the graph is going to move left or right corresponding to the number you've added or subtracted on the inside of the parentheses for that cube function. Okay, cube root also works the same. Here we have my cube root function, 0, 0 point. Okay, remember that the cube root function is more flat and wide. Okay. In order to signify an inside change for the cube root function, we have to have the +2 or the -5. We have to have that number underneath that radical symbol. So the bar has to extend over it. So what would be an outside change? So you'll notice here, if I add a 5, you notice that 5 right there is outside of the cube root. It is not underneath that bar. So this +2 would be an inside change, but the +5 would be an outside change. Okay. Cube root of x plus 2, that's going to take my cube root function and shift it to the left 2 units. So that 0, 0 point now is going to be moved to -2, 0, and then the shape will come from there. Okay, so we see that that is true. Cube root of x minus 5, the -5 is underneath that bar for that cube root function. So I'm anticipating it's going to shift the graph to the right 5 units. And the newly shifted origin point would be 5, 0. Okay, once again, the shape itself does not change, just where we've shifted that origin point to. Okay, so that brings us to another question. Can we make inside changes and outside changes at the same time? And yes, we can. So let's go back up here to this one. The cube root of x plus 2. So we said that that plus 2 on the inside would move the graph to the left 2 units. But what if we add a 5 on the outside as well? Okay, so what we see is we've had two changes here. So we moved 2 units to the left, and then we also moved that origin point 5 units up. If we add a 5 on the outside, that would shift our graph up. So we have two different changes, an inside change and an outside change, that would shift us to the left 2 units first, and then up 5 units. And so the newly shifted origin point for this graph, which might be hard to pinpoint there for us, is -2, 5. 2 to the left and then 5 up. Okay, so what if I take this function here and we've subtracted a 5, so we saw that. So that moved to the right 5 units because we subtracted that 5 underneath the cube root symbol. So that's an inside change. So there we were. Can we make an outside change? So let's come up and say plus 1. So that shifts the graph to the right 5 units still, but then up 1 as well. So 5, 1 to the right 5 units and then up 1. Okay, what if we subtract a 1? What is that going to do? If I subtract 1 on the outside, that's going to shift the graph down. So on the inside, we would shift to the right 5 units, and then on the outside, we would shift down 1 unit. So our newly shifted origin point would be 5, -1. So we can have both inside changes and outside changes to all of our basic shapes. And we want to keep track of which ones are inside, which ones are outside, and what effect does that have on our graph, and how does that shift that origin point. Okay, so let's go back to our notes and do some examples. Alright, so we come back to our notes here, and let's say that we were asked to graph g of x equals absolute value of x plus 2. If I added 2 on the inside of those absolute value bars, then what effect does that have on our basic shape? So we're talking about absolute value, so the first thing that I'm going to ask you to do is to think about what is that basic shape. So the basic shape, when I read that, I say absolute value. So I know what my absolute value shape looks like, and I know where the origin point is located on that basic shape. Okay, and the second thing we're going to do is we're going to talk about the change that has been made. So we have added a 2 on the inside, so that's important. If we add a 2 on the inside, then that means that we have a horizontal shift. And since we see plus 2, then we know we're going to move to the left 2 units. Okay, we always start at the origin, so we always start at the very middle at 0, 0. And if I move to the left 2 units, that puts me at an x value of -2. So I'm going to put a point there, and I'm going to label that newly shifted origin point, -2, 0. Then I'll draw my basic shape from there. So there's my absolute value basic shape shifted to the left 2 units. Okay, can you tell me the domain and range of that? Okay, so the domain looks like all real numbers from -infinity on the left to +infinity on the right. Our range, we start at the very bottom of the graph. Remember, we want what's the y value of that point. The y value at the very bottom is 0, and it's included. So I put closed brackets. And then when I go to the very top of the graph, the y values are basically getting larger because of those arrows pointing up. So from 0 to +infinity with 0 included. Okay, so what about this example here? What if I have h of x equals absolute value of x minus 1? So the -1 is being subtracted on the inside. So we know our basic shape is that absolute value shape, but now we have a horizontal shift in the opposite direction. So for this one, a horizontal shift would be to the right 1 unit. So I'm going to go to the origin. I'm going to shift to the right 1 unit. So that's an x value of 1. And I'm going to plot that shifted origin point. I'm going to label it. It's an x value of 1 and a y value of 0. And then we're going to draw in our absolute value v-shape from there. Okay, your graph doesn't have to be perfect, but it should be good enough to tell me the correct domain and range. And the shape itself should be identifiable. So when I look at your shape, I shouldn't be confused. Is that a square function or cube root function? It should be identifiable as the absolute value, and it should be good enough to where you can tell me the domain and range. So when I go to the left, I see an arrow. I go to the right, I see an arrow. So that's all real numbers for our domain, negative infinity to positive infinity. For the range, when I go to the very bottom, we want to know what's the y value of that very bottommost point, and the y value is 0. Included. Then we go to the very top, the arrows are pointing up, tells us that the y values are increasing forever. So from 0 to infinity, including 0 for that range. Okay, let's look at some examples. So we're going to tell how the following graphs would be shifted. So our goal is to sketch the new graph and include the label for the new location of that shifted origin point. So here's part A. F of x equals, we have parentheses, and I have x minus 2 inside, squared plus 3. So that's x minus 2 squared plus 3. Which basic shape name did you hear when we read that function? So hopefully you heard the word square. So our first step is to identify what basic shape are we talking about. So you hear the name of that basic shape when you read that function, and so to think about what's that basic shape, that's the square function, that's that U-shaped graph, and I want you to plot the origin point on that shape. So that's at the very bottom of that U-shaped graph, we have 0, 0. Okay, so the second thing we're going to do is we're going to identify the shifts. So what shifts do we have? Those are going to come from, remember, adding or subtracting things on the inside and outside. So I have a negative 2, so that 2 is being subtracted, and is that inside or outside? Okay, so that's an inside change. So we subtract a 2 on the inside of the square function, so on the inside of those parentheses. That's going to move our graph to the right 2 units. So that represents a shift to the right 2 units. Okay, what about that plus 3 that we've added? Is that inside or outside? Okay, that's an outside change. Okay, if I add a 3 to the outside of one of our primary functions, that's going to shift our graph either up or down, and if I see a plus, that's going to shift the graph up, in this case 3 units. Okay, so now we're going to draw a picture. Okay, so I'm going to shift to the right 2 units. And then we're going to shift up 1, 2, 3 units. Okay, so we're going to start at the origin, go to the right 2 units, and then we're going to go up 1, 2, 3 units, and then we're going to plot our point. Now what I want you to be able to do is to label that point with the correct x and y labeling. That's an x value of 2 and a y value of 3. Okay, after we've shifted that origin point and we have labeled it, then we're going to draw in our basic shape from there. So we're going to curve up and to the right, and we're going to curve up and to the left. So we should have that square function shape with that point at the very bottom, but now it has a new label of 2, 3. Okay, something else that you should be able to do after you've drawn your picture is to tell what is the domain and what is the range of the shape that you just drew. Okay, so the domain, I start at the left, I see an arrow, I go to the right, I see an arrow, so that's from negative infinity to positive infinity for the domain. For the range, we want to record all the y values from bottom to top. So when I go to the very bottom of the graph, what's the y value there? And that's a 3. And that 3 is included. Remember we said we assume included unless we see a open circle. So 3 is included, so I'm going to put a closed bracket. So the y value of 3 is at the very bottom. We're going to go to the very top. I see arrows, and so that tells me the y values are increasing forever, so positive infinity. Okay, so you should be able to look at this equation, tell what the shifts are, shift your origin point and label it, draw in that basic shape, and then after you've drawn it, you should be able to tell what is the domain and range of the picture that you drew. For part B, our function is h of x equals the cube root of x plus 5. So when I said that function, I said the name of one of our basic shapes. So what name did you hear? I heard cube root. Okay, when you see the radical symbol, that little V shape with a number above it, that's when you say root. So this is the cube root function, and so I know that the cube root function has that origin point 0, 0, and then we curve up and to the right. We know it's more flat and more wide than the cube function. And then we come down and to the left, still more wide and more flat, pointing more toward the left. So there's our cube root function, there's our basic shape. So that's going to be the first step of all of these problems, is to identify what basic shape are we referring to. Okay, then step 2, we're going to talk about the shifts. Now, in the last example, we had both an inside change and an outside change. But in this example, it looks like I only have an inside change. So I'm only adding a 5 on the inside. So that's underneath that cube root symbol, underneath that radical. So that's an inside change. There is no outside change. So I don't see anything being added or subtracted on the outside. So no outside change. So what are the shifts? Well, if I add a number on the inside of one of my basic shape functions, we go in the opposite direction of the sign. So instead of moving to the right because I see a plus, we're going to the left because we see a plus. So remember, on the inside, it's always opposite sign of what you might think. So we're going to move to the left 5 units. And then there is no vertical shift. So we have nothing added or subtracted on the outside, so there's no vertical shift in this case. That is fine. We don't have to have both a vertical and a horizontal shift. Okay, so now we're going to draw our graph. Okay, so we're going to start at the origin point 0, 0, and then this tells us we're moving to the left 5 units. Okay, we're not going to move up or down at all. So we're just going to move 1, 2, 3, 4, 5 units to the left. And that's where we're going to plot our point for our graph. So that's what we call the shifted origin point. So I want you to label that. That's -5 for x and a y value of 0. So we always want to give the x and y label of that shifted origin point. Okay, so after we've done that, we're going to draw our basic shape in from there. So we're going to always start at that origin point, and then we're going to curve up and to the right. And then I go back to the origin point and I curve down and to the left. So when I draw cube and cube root, I always do it in 2 parts, always starting at the origin point and then curving from there. Okay, so after we've drawn in our basic shape, I'm going to ask you what is the domain and range of the picture we just drew. Okay, so if I go to the left, I see arrow. If I go to the right, I see an arrow. So my x values go from -infinity to positive infinity, all real numbers. Okay, what range? Start at the bottom. I see an arrow. I go to the top. I see an arrow. So the range here is also -infinity to positive infinity. Let's look at example part C. We have g of x equals x cubed minus 5. So when I read that function, what name of one of our basic shapes did we say? Okay, so you heard cube. So step 1 is to identify the basic shape that's used in this function. And so that's our cube function. You can draw our little grid if you want. So our cube function has that 0, 0 point at the center and then curves up and to the right, so it's going more up, and then it curves back down and to the left. So remember, it's more tall and skinny than the cube root function. Okay, so there's our cube function. That's our basic shape that we're going to use when we graph. Okay, our second step is to determine what are the shifts of that origin point. Okay, so here I do not see the parentheses this time. So this time there is no inside change. In order to have an inside change with the cube function, you have to see parentheses around the x, and then you have to see something happening inside of the parentheses besides x. So here there's no inside change because there's no parentheses. So the -5 that I see is actually happening only outside. So that's an outside change. Okay, so what does it mean when I have a -5 being subtracted on the outside? That means we're going to shift the graph down 5 units. So remember, outside changes, we move the graph up or down according to the sign we see. Okay, so now we're going to graph it. Okay, so I'm going to end up moving down 5 units. It's going to make 5 tick marks here and label them. Okay, so we start at that origin point, and I move that origin point down 1, 2, 3, 4, 5 units, and that's where we're going to plot the point. So I'm not going to move left or right at all because we had no inside change to move the graph horizontally. So just that vertical movement down 5, that's it. Plot our point, and we're going to label that as x value of 0 but a y value of -5. Okay, so after I've plotted and labeled my origin point that's been shifted, now I'm going to draw in that basic shape from there. So I want this to look like the cube function. So I'm going to go up to my point, I'm going to curve up and to the right, put an arrow, then I'm going to curve down and to the left, and then put an arrow. So that looks like my cube function shifted down 5 units. Okay, after we shift, we want to look at what is the domain and range of the picture we see. Okay, so my domain, I go to the left, I see an arrow, so that's -infinity. I go to the right, I see an arrow, so that's +infinity. So -infinity to +infinity. Remember, we always put parentheses next to infinity. Okay, what about the range? For the range, we go to the very bottom of the graph and look for the smallest y value. But I see an arrow, so that's -infinity. And then I go to the very top of the graph, and again I see an arrow, so that's +infinity. Okay, we're at part D. We have m of x is equal to the square root of x plus 1 and then -4. So when we say that function, what name did you hear that registers as one of our basic shapes? So hopefully you heard the word square root. Now remember, when you see that radical symbol, that V shape with the little line across, that's when you say the word root. So our basic shape is that square root basic shape. Okay, so we're going to start at the 0, 0 point. And then the square root function curves up and to the right, and then that's it. Okay, so it doesn't have that tail to the bottom left. So there's our square root basic shape. The second thing we want to do is identify if there's any shifts. Okay, so I see a +1, and that +1 is underneath that square root shape, that radical symbol. So that bar that goes completely above the +1. So for square root, that's what we need to call it an inside change. we see that the -4 is not underneath that bar, is not underneath that radical. So the -4 is what we would call an outside change. Okay, so if I add a 1 on the inside, that's going to shift our graph which direction? Okay, good, to the left. So going to opposite direction of the sign. So it's going to shift to the left 1 unit. And then what do I do when I have a -4 on the outside? Okay, good. We're going to shift down 4 units. Okay, so now we're going to do the graph. Okay, we'll just do a little bit of labeling. Okay, so I'm going to start at the origin point, and we're going to follow our directions. I'm going to shift 1 unit to the left, so that puts me at an x value of -1, and then we're going to shift 1, 2, 3, 4 units down. Okay, so we're going to plot our newly shifted origin point, and we're going to label that. That's an x value of -1 and a y value of -4. Alright, once we have our shifted origin point, that shifted point labeled, now I'm going to draw in the basic shape. So in step 1 I have that basic shape, and so I know I'm going to curve up and to the right of that shifted origin point. Okay, so now we want to tell what is the domain and range of this graph. Okay, so remember that domain are the x values, and we always go from left to right. The range is always the y values, and we always go from bottom to top. Okay, so let's look at our domain. So I'm going to take my pencil again. Remember, I'm going to turn it vertically. And so I want to say, what x values does the very leftmost point of my graph line up with? And so it lines up with an x value of -1. So on the very far left of our graph, we have an x value of -1, and it's included as part of our graph because we see a closed circle. Okay, and then I go to the very far right. Remember, I'm using my pencil, curving to the very far right. I get to an arrow, so that's positive infinity. Okay, what about the range? So remember that the range starts at the bottom and then goes to the top, and I turn my pencil horizontally. So now I'm down like this, so that's the very bottom of my graph. So the very bottom of the graph, that lines up with a y value of -4. So that's -4, and it's included because we see a closed filled-in circle. And then we go up to the top of the graph with our pencil turned horizontally, and we see an arrow, so that implies positive infinity. Okay, so you should be able to draw that picture, label the shifted origin point, make sure you have the right shape, and then once you graph it, you should be able to tell me the correct domain and range of the picture that you just drew. For part E, we have g of x is equal to x minus 4 in parentheses cubed plus 2. So when we say that function, when we read it out loud, we said the word cubed. So we're looking at the cube function, that's our basic shape. Okay, so we have our origin point, 0, 0, and the cube function is tall and skinny, curves up and to the right, pointing more up, and then down and to the left, pointing more down. Okay, next we're going to identify any shifts that we see. We see the parentheses this time, and we see a -4 inside of those parentheses. So the -4 inside of the parentheses being cubed is an inside change. Okay, I also see a +2 on the outside of the parentheses and outside of the cubing, and that's an outside change. Okay, so if I have a -4 on the inside, what's the shift? Okay, good, that's to the right 4 units. If I have a +2 on the outside, what's the shift? Okay, good, that would be up 2 units. Okay, now we're going to graph this. Okay, so we start at the origin. To the right 4 puts me at a positive 4 for x, and then we're going to shift up 2. When I go up 2, that puts me at a positive 2 for y. So we're going to plot our point, our newly shifted origin point there. We're going to label it. That's an x value of 2, sorry, an x value of 4 and a y value of 2. So 4, 2. Remember, it's always x first, y second. And then after I plot my newly shifted origin point and label it, I'm going to draw in my basic shape from there. And so we know for step 1 that we drew that basic shape. We're going to curve up and to the right, and then we're going to curve down and to the left. For part F, we have the equation m of x is equal to cube root of x minus 1. So when we said that out loud, we said the words cube root when we read that function. So we say the word root when you see that radical symbol with that V shape and that bar over it. And so it's a cube root because we see that 3, and then it's a root because we see the little V-shaped portion with the bar. So first identify that basic shape. Okay, so our origin point, 0, 0, we're going to start there, and then our cube root curves up and to the right, but is more flat and wide, more pointing toward the right. And then it has a tail, curves down and to the left, curving more toward the left. Okay, so make sure you can tell the difference between the cube root function and the cube function. And make sure that when you draw them, there's a difference. Okay, so the second thing we're going to do is we're going to look for any shifts. Okay, so when I look underneath that cube root symbol, I do not see anything being added or subtracted. So there, in this case, is no inside change. So that means that there is no horizontal shift. Okay, I do see a minus 1. What is that minus 1 telling us to do? Well, the minus 1 is on the outside, so that's being subtracted on the outside. If I have a number being subtracted on the outside of my basic shape, then we shift down 1 unit. All right, so we shift down. Okay, so now we're going to graph it. Okay, so I'm going to go back to my origin, get rid, and we're going to shift down 1 unit from that origin point. So I'm going to shift down 1 unit, then I'm going to plot and label my newly shifted origin point. So there's my origin point. That's an x value of 0 and a y value of -1. Okay, once I plotted my newly shifted origin point and I've labeled it, I am going to go back to drawing my basic shape from that location of that origin point. So we're going to curve up and to the right from our origin point, and then we're going to curve down and to the left. So you want to make sure that it looks very much like the original basic shape, just has a different location for that origin point.